So go over to announcements, and there's two announcements in there. The first one we want to look at is just the welcome one. And basically it just gives you a link to the syllabus. It gives you a link to a Canvas tutorial. And then you got the information down here on how to sign up. And I'll try to take you through that a little bit later. All right. So let's just look at the syllabus first. So click on that. And then I'm going to have to reshare that screen because it opens up in a new tab. Uh-oh. What happened? Oh, I got it. My computer. I'm getting I ordered a new computer. It's coming on the way because this one's kind of old and it's slow. So, syllabus. So the syllabus pops up in a new screen. And that's you, WT4, the 11 o'clock class. Try to inject a little humor in here for a few things. So we meet Tuesday and Thursday, 11 to 1:30. My office is at 126B, but as of now, I'm not back there. I don't know when we're going to be going back. As far as I know, faculty haven't, not doing that yet. They've got some of the staff back, but so for right now, those are right here is the best way to contact me. Be glad to meet with you online like this one-to-one if you want to. So that'll kind of take the place of the regular office thing. Another little bit of humor about, because everything is really in this syllabus addendum. So if it's not, like I said, it's not written. If it's not written in stone here, then it's kind of open for debate. This is what way the policies work. All right. So the most important thing about the syllabus is this course pacing guide. And the bad thing about the summer is that it goes incredibly fast. The good thing about the summer is it goes incredibly fast. Like during the regular semester, there's more days to play with. So you got kind of, breaks between due dates. And in the summer, it's just really hard to do that because you're essentially squashing 2 weeks into 1 week. So, there's no really way around that. I do have as much flexibility I can put in there, like for homeworks, the due dates, you can still work on one after the due date. But like I said, for tests and this and that, we kind of gotta, we can't draw those out because we got to be able to squeeze them all in. I do have procedures for you if you miss one, but generally that's not the best thing to do. All right, so this is a pacing guide. The first thing I got on here is something that's just primarily for you folks, because in this online class, we got to make sure that you can test appropriately. So I'll show you where this is at in a second. It's back over in the Canvas area. But you need to just make sure that you got the equipment in place to be able to use this lockdown browser. And it works with Windows. I know that for sure because I've done it. And I think, as I understand, it works with Mac. Sadly, and this is part of what I'm bothered by it, because I use Chromebooks an awful lot because they're really, really efficient and also don't cost much. But you can't use a Chromebook to do the testing. You have to do it on either a Windows or Mac computer. So the reason why I got this is the due date is the 15th is because the department had said, make sure the students go through that check before the drop date, what they call the census date, because you don't want to be taking this if you can't do the, those tests. And I'll show you in a second where that's at. We'll come back to that because I'm going to talk about all these tests in a bit. Now, there's two kind of main areas. There's the Connect math, which contains your homework and quizzes, and that's about 25% of the grade. And if you don't know, Connect Math is like My Math Lab, or if you came from Math 30, 130, or if you came from Math 20, it's sort of like Alex. It's not progressive like Alex is. It's deals with homeworks, whereas Alex has got that kind of path thing. But it's just online stuff you got to do. And like I said, it's about 25% of the grade. So the course is broken down essentially into 4 quarters, like a football game, basketball game. You got before midterm, or up to midterm, you got 2 sections. The first one covers 3 chapters. All right. And there's not a whole lot to chapter 1. It's not really even there's no calculations in there. It's just kind of like definitions and such. So when you see these things used, these definitions used throughout the course, you'll know what they mean. Chapter 2, and notice that there's one homework assignment in there, and then a quiz that kind of helps making sure that you know the material. The difference between the homework and the quiz is the homework has got helps. You can ask, ask for an example. You can go to the textbook, and you can send the note to me about it. With the quizzes, of course, there's the helps are turned off. It's more like a test. So we'll talk about the weighting in a bit. So you got that first one, and then chapter 2 has got 3 homeworks associated with it. And that's, again, we'll look at that today. Graphical summaries of data. And then it's got a little quiz associated with it. And you can kind of see over here on the left, these are the due dates. Okay. And see how they're all stacked together. I mean, there's not really any way around that because, like I said, I tried not to make things too heavily due on weekends, but since we kind of officially got a 3-day weekend because school is closed on Fridays, I have to kind of sacrifice one or the other because there's just really not enough days if you only use the 16 days in the month that we got, 4 times 4 weeks times 4 days. Anyway, and then chapter 3, which is where you start getting into calculations. It's broken into 2 sections and then a quiz, and then 1 section that's a little bit larger and a quiz. And then once we finished with all that, this right here is my little test for you. Because the reason why I say it's my test, it's on Canvas, and it's not the departmental exam, because we have a departmental final exam at the end, and then we should have a midterm as well. But we'll kind of see how it goes with this. I mean, if I don't get it early enough, because they got to send it over here, and I'm not sure how they're going to do that. But anyway, you got a test in Canvas, and I'll show you that in a bit. And then that kind of brings us up to the first quarter, and then the second quarter is chapter 4 and chapter 5. Chapter 4 has 4 sections, and there's 2 sections to each one of those quizzes. Chapter 5 is really pretty short, and it's only got 1 quiz associated with it. 5.1 is really almost not a whole lot to it. I say 5.2 is really the only thing that's 5.1 is almost related to 4, and 5.2 is kind of new material. The probability, it's a whole different kind of thing than what comes. If you had Math 120, this first half, for the most part, is kind of a review. It's a little bit more in depth, but anyway. I know how I teach 120 sometimes too, and I know that a lot of students don't like probability. It's chapter 10 and 11. It's the third one. It's the third chapter. And then that brings us up to almost midterm. So we got the test 2, and like I said, I have the midterm listed in here, and we'll kind of play that by ear. All right. And then that brings us up on July 1st. Actually, that's when you get to see the end of the midterm period, and you should see midterm grades. And if you're not familiar with that, the midterm grades are non-binding. It's really strictly a progress report. You know, if you have an A at midterm, that does not mean you'll have an A at the end of the term. And if you have a F or a D at the midterm, that does not mean that you're going to be stuck with that, because I have, you know, if you miss a test, you know, it's going to really throw your average off, but I have a way for you to make it up towards as we go along. And then after midterm, we got 2 chapters. And again, they're broken into 2 sections with 2 separate quizzes on chapter 6. And then the same thing with chapter 7, 2 separate quizzes on the 3 different chapters. I mean, sections in the chapter. And then a test 3. And you notice I kind of have a little window in there for you to take it. And again, the window's not that big during the summer, but you know, I do want to give you some option. And then you can almost finish that test 3 before the final drop date. It's not due until the 8th, but it is opened up on the 6th. And again, preferably in a regular semester, I would like to have that test, you know, in before that final drop date, because people like to know where they stand. And then after that final drop date, the fourth quarter, you have 2 more chapters. Chapter 8 is 4 sections, and then it's divided into 2 little quizzes associated with the 2 sections, the 2 groupings. And then chapter 11, which is pretty short, and that's the last one. So that's 9 chapters altogether. And then we got a test 4, and then the final exam is going to be July 22nd to 24th. I think the 21st is the last day of class. And so, all right, any questions? If you got questions that go along, type them in, or you can yell them out. All right, and why it's important, especially for this final exam, about you got to use that respond. There's no way around it, because what it does is, if anybody's ever used that, it essentially locks the browser down so you can't open up any windows. And personally, in this class, I don't think that's really all that necessary, because you know, you could have all the windows you want open. Statistics is really hard to cheat in, but that's the departmental regulation, so we got to go by. All right. So let's go down and just look. I got attendance policy there. I take attendance because that's Delgado wants me to do it. I don't use that to hurt you. I think generally it's good to come to class, but you know, I'm going to have these things hopefully available at least for 2 weeks, the lectures for you to visit, you know, go in and see. So you've got options here, but it'll never hurt your grade. It could make it better, you know, if you're like right on the cusp of a grade, that type of thing. And this is something else I'll show you in about how to get the text. I would recommend the online version. It's cheaper, and you got everything you need. I'll show you that in a bit. And I like using Excel for calculations, but the official calculator, and the one that they use in the textbook and PowerPoints to show you how to do, is the TI-84 Plus. Now, I personally don't. I hate to make students go out and pay $100 for a calculator that they won't use ever again, because unless you're taking some other math classes, higher level math classes, you know, you're not going to use that thing. You might find a use for it, but I doubt it. If you want to buy it, that's fine. But I have a way for you to download it onto a Windows computer, and I'll show you that over there in the modules where you can do it. And I'll show you what it looks like. And you can also do the same thing for Android. You Apple people, you're on your own. So I don't know what to tell you, because there may be something, but usually with Apple, you got to pay for stuff. Plus, I don't know if they have anything, because there's all those rights and stuff that Apple enforces. All right. So the last thing is just how the grade is broken down. 65% of the stuff that you do for me is broken down into homework and Connect is 15%. The quizzes are 10%. And then the Canvas tests, my Canvas tests, those 4 tests are 40% or 10 percent each. And then the final 35% comes from that midterm and final exam. All right. And just remember, I'm going to put it here. You can also use ProctorU if you want to, but it basically does the same thing. It's just that it doesn't cost you anything, because with ProctorU you got to pay them, but they kind of watch you and record you, and they send me the recording. Well, the same thing with Respondus. I'm the only one that can see it, because I can see what you're doing. All right, so you got to make sure you got to take these things during those dates that they're available. I try to make homework available as long as I can, like everything for the first half of the semester or the session is available up until like that midterm point. I think it's the 30th. And then after that, the second half of the homework will be open up towards the end. But the quizzes and tests just don't give you that option. They got to close at a certain point. So there's not going to be individual makeup tests. I got the way to do that with the midterm and the final exam. Make sure you keep up with these dates, because this is just what I would just say as a warning. If you wait till that last deadline period, especially with a test, I mean, homework is not such a big issue because it'll still be there. When you go in, say a test is an hour, and you go in at 11 o'clock and you have computer problems, or your internet goes down, or something happens at Connect Math, or, the proctor, whatever happens, not available, then you can't, those aren't acceptable excuses. All right. Just keep that in mind. And then also towards the end, once we finished everything but the exam, I'll have that final grade in there with everything but the final exam for you. So then where that missing 25% is going. You'll have the first 75%. You'll know where it is, and you can essentially add your final exam once you get it, and then divide by 4. All right. And I got the instructions there. If you need help as we get closer, I'll help you. I just wanted to mention these things. You're going to have access to a computer. Of course, if you're in here now, I'm sure that you have that. Maybe you're on a phone. You might be able to do most of the stuff with a phone. I don't think you'll be able to do the tests with a phone because, as I said, you're going to need to have Windows computers. I've never done the. I know you can't do the Respondus on a phone, but you can work in Connect Math, as I think, on a mobile device. I've just not done it, but I understand it. You can do things on there. You can do the homework for sure, and you may be able to do the quizzes, but that I'm not going to recommend that, just because, if you want to try it, make sure you give yourself a lot of leeway on the before the deadline to do it. All right. You got to make sure you sign up for Connect before the 7th day of class, which is June 15th, because I've never had, I have a hard time. Let me back up. Generally speaking, people that don't do well in the class are the people that start later, and especially during the summer, You got so little time to work with, so it's best to start as immediately as you can, immediately. And I've got everything in place for you to do that. All right, so let's go back over to Canvas and look at the things we got over there. All right. I'll just try to. So under modules, you've got pretty much everything you need. This is how you get into Connect Math. I'll show you that in a second. Here's the it's the TI-84 Plus. It's called WabbitEmu for some strange reason. You know how things are on the web with apps. You download these two files onto your computer, your Windows computer. You run the .exe. You got to click on it, and it'll ask you to point to this other file, and you got to do that. Once you do that, you will have something that looks like this, and I'll show you. And like I said, it looks exactly like the one that you would buy, and it's bigger. And like I said, there's also a way to do it on your phone. If you want to do that, just search the store or the Play Store, whatever, in Android for WabbitEmu, and then you get the one that's closest to this. I think it's like Silver Edition or something, because that's one I got. But you can kind of see it. So it looks like a calculator, just like that one. Like I said, I hate to make students go out and buy stuff. You shouldn't have to go out and spend money anytime you want to learn. So, all right. So, what else? All right. Let me show you where the quizzes are at. Or where the tests are at. There's not a section in here called tests. It's called quizzes. And as far as I know, I can't change the name of it. But this first one is the one I was talking about, which is like the practice thing. There's no grade associated with that. You just really need to do it to make sure you're going to be able to be set up for when the midterm and final come about. I'm not really worried about on these other four of mine about using the respondus, because like I said, in my opinion, for my test, it's really hard to cheat in statistics. So until I am no longer of that opinion, they're going to stay where you don't have to go through the respondus. There's the 4 chapter tests, that each of them which are 10%. All right. So you just basically click on that and start. So when you get the chance, I would really like to see everybody do that first one. It's not a whole lot of questions in there. It's just something to make sure you've got the. That's a good question. I don't really. I'll have to think about it if there's a way to do that. I know what you're saying for the exam, since it's using respondus. Obviously, that's not going to work. So that's why I'm pushing the calculator. I'd much rather see people use the Excel personally, because I don't think it gives you any advantage other than it's really just more convenient. If you ever try to input a data set on a calculator, it can be very, very time consuming. And the way that the tests, like the little quizzes and the homeworks work in Connect, they allow you to download the data. So that way you're assured that you got the right data. So as we get closer, I'll kind of think about if there's a workaround on that. But that is a good question. You might just have to do it on another device because, like I said, I'm the only one that's going to be looking at that video. And as long as, like I said, you're not talking and phoning a friend kind of thing, that's the only one I really don't want people doing. And just because it should be your, work on the test. So, but that's it is. I just didn't quite put those two together. So we'll think about that, and I'll try to give you an answer as we get closer. You're not going to have to worry about it on these 4, obviously, but it's at least the final exam is an issue. All right. So what are we else we doing here? All right. Back over in modules. Okay, that's the teacher's notes. That's generally what I use to guide or at least part of the lectures. Sometimes I use some PowerPoints that are specific to the book, and those are right here next. And the notes don't have, in some sections, like for example in chapter 2 and chapter 3, they're not nearly as comprehensive as something like chapter 1, because when you're dealing with textbooks, with statistics, sometimes there's things that people don't agree with. It's not like with algebra where we've been doing this for years and years and years and years, and pretty much everything's the same. With statistics, there are some small issues where different textbooks and people don't agree. So I try to stick on certain things to what the book does, so that way you don't run into trouble with the homework. All right. So what I'll do, like for example, in chapter 2, I'll look at the chapter 1 notes when we go over chapter 1, but the chapter 2, I'm going to use the PowerPoints just to kind of be safe. So that's the PowerPoints that I use. And then final exam review, all down there. All right, so let's just go ahead and look at this one last thing over here. And this is how you get into the Connect Math. It's linked to Canvas, the Connect Math, so you don't need a class ID or a course code. Matter of fact, let me do it as a student, so it'll be more tuned with what you're doing. Because I can't really go through the procedure as a teacher because it works differently. So as a student, you click on that, and the first time you'll do it, you got to go through and click all these I agree things, sign over, 10 years of your life and all that type of thing. Anytime you use something online, you got all those strict agreements. Okay. The things that nobody ever reads. Now, the first time you do it, you'll click on this, and I do believe that every time you do it, you'll have this button. It's just that what comes next for the first time user is oops, I gotta reshare because it opens up a new screen. But once you click that, you actually go into Connect. But the first time you got to do the sign up. So for the most part, you are going to keep it on that default, which is no, I have never used Connect Math. Because you would not have a Connect Math course, a Connect Math account, unless you are repeating this course. If you took this previously and you signed up, then you will have an account. And if you paid, and you definitely want to do yes and log into that account, because otherwise you will have to pay again. You have to go into your account that you used in a previous iteration of this course in order to get that. But if you do that, good thing is you save yourself 85 bucks. All right. So what you can do for is do continue. So I'm just going to put the little name in here. It may not. Let me do this since I already did it. Might have to come up with another email. Let's see. Probably say you've already got an account. What let's say. Since it doesn't match, let's see. Glasses. Oh, here we go. All right, I'm just going to put the school address. All right, let's see. Because I'd like to show you the next step. All right, that's what we can. All right, so now this is what kind of does the pairing. Now, instead of going directly to Command Math, you can go through the Canvas to get there. That's why you don't need a course ID or course code or whatever. So I do believe you can go and log into Connect Math separately, but you don't have to. All right. So now you're going to have an access code. Now, at some point, unless you, because are repeating the course, you're going to have to purchase. All right. And then so when you go in, you can purchase it online and $85 and you'll get that instant access. If you happen to have a book that's got the course code in it, you can just type it in there. Now, what I have over here, and in that announcement at the bottom, is this fancy little thing that gives you 2 weeks access. Because I don't really like these things because I think they encourage students to think that they're not going to have to buy it or they can just test the waters. But you got to realize the danger of this. They're not going to let you go any longer than 2 weeks. And they don't care if you're doing something important, like you're taking a test. And so this thing is going to die in exactly 2 weeks from the time that you put it in, which is right around test time. And maybe that's one reason they do it. But you do that, and that gives you 2 weeks temporary access. And see, it expires on 6/21, which is about when we're going to wrap up the first quarter. And then you just go through the process. Need these things. And this is where you extend your access down there at bottom. It says blue. And that'll just allow you to purchase it online or put in the code from a book. You go in. And there's your start of your homework. Chapter 1, homework, and then quiz. Chapter 2, homework, and then quiz. And there's more. I've got everything through midterm showing up. Well, actually, I'm sorry. I'll take that back. I got everything through the first quarter showing up. Everything through chapter 3 showing up. You can also see that these are going to come later, but you won't see them until after that first test. All right. Any questions? Ask me something. Challenge me, because I just get tired of hearing my own self talk, and I want to have time to get my brain working. Sometimes talking, it's just too easy and running on and don't realize I'm leaving out something important.
I have a question. I saw on there the test. I know that it might change, but it said that it had like 10 questions like per test. Is that usually about the amount of questions we have on those?
Okay, for those, yeah, for those that are mine, yes, that's correct.
Okay.
I'm surprised you could see that, but yeah, they're rather short. And I think even for you folks, since this is kind of experimental summer session, you can do them twice. So,
Okay. Perfect. Thank you.
yeah, you just can't see the answers until you submit it, for the final time.
Yes,
All right. But for the exam, it's a little bit longer. I think it's closer to 30 problems, but you got longer to take it. You got a 2-hour time limit, which is with the the chapter tests. Is what I call them, the 4 chapter tests. I think it's like 45 minutes you got, because they're kind of designed to take within class time on on a class that meets for 50 minutes. Can't really go much longer than that.
Is that the only chapter test we're going to be taking, or are we going to have to take something else also?
Except for that midterm and final exam and those quizzes.
Yes. Okay. I was just making sure that it wasn't something else that we was going to have to take.
No, I kind of redesigned things explicitly for this summer session. So in the past, I had actually had probably more work, so maybe you might have heard things, but I've kind of toned it down. But
okay, perfect. Thank you.
Okay. All right. So let's see. Explain the how the grading works. I think that's about it. I guess what I'll just do is one more thing, so I don't before I forget it. Is there's also an announcement that I send out as well, and you got it a little bit earlier than I probably would have done. I probably would have just sent it before class just to not give you too much to go over. But for that next class, assuming that we don't have some kind of big hurricane issue that we, in lockdown and evacuated, next Tuesday, if you bring a bag of M&Ms, and usually the best ones to bring is the plain ones. If you have a bigger bag, of peanut or something like that, it kind of compensates for it. But we can just do a little in-class demonstration of how sampling works, which is what we're going to talk about today. And what I'd like to have you do before you show up for class is just count the number of M&Ms in the bag, and then count the number of each color. And then once you got those, just make sure you write those down. And what we'll do is hopefully, if we have class, I don't know. I'm always just, it seems like every summer or every other summer we end up losing time, but I don't know what's going to happen because there's no school to close, building to close. So anyway, we'll see how it goes. But just bring that for the next class. All right. So as I said, is the notes that I'll be looking at. Oh, you know what? And I didn't show you. I didn't broadcast where that's at, but it's in the announcements, because I always forget to change this. But that M&M announcement is right here if you want to click on it and see it. But it should have come out to your default email. And so to start, and like I said, this probably take about 15. Let's say minutes to go through this, and then we'll take a little break. All right, so right here, the teacher's notes, if you click that, it opens up into a different window. So let me share that with you. And then we'll just kind of go over the basics of chapter 1. Oops. I'm actually in the process of updating this computer, getting another one, because this one, it's old and it's slow, my Windows computer. I knew it was going to do that. All right, I'll just share them with this. I'm starting this back up. All right, so this is the notes that I use and I make available to you. And like I said, for chapter 1, it's really very simple chapter. It's just mainly definitions. So let's just go through these. There's 2 categories of statistics. There's what's called descriptive statistics, and then there's inferential statistics. The second half of Math 120, if you had taken that, that's really descriptive statistics. And that's what we're going to go over basically through chapter 3, 1 through 3. It's basically collecting, organizing, summarizing, and presenting data. All right. It's nothing really subjective about it. It's all just very objective. Everything's calculated the same way for all data sets. So it just tells you things like what we call the mean, median, mode, standard deviation. And we'll look at those next time. And then the second kind of statistics is what we call inferential statistics. Inferential statistics is the art of drawing generalizations, judgments, or predictions about a population using generally a sample and those calculations that were done in descriptive statistics. Now, there's 2 important things in here, okay? Or 3 important things. We mentioned data. Well, data is just information that's collected and used that's using an experiment or observation. So one is kind of theoretical and the other is what we call empirical. So like an experiment is going and taking a die and rolling it one time and recording what you get on that die. Or you flip a coin and record what you get. And you perform that experiment in number of times usually. N is kind of the variable, just meaning however many times we're supposed to do it or how many times we say we're going to do it. And then the observation generally comes from data that's collected and out in the world, okay? So if we wanted to go through every student in here and find out what their eye color is, I would go and ask and write it down, go and ask and write it down, go and ask and write it down. All right. One of the things that I had done in the past, and as I'd have students go out at this time of in the semester at the very beginning, and just take 3 or 4 surveys from people they knew, and we'd take that data and we'd work with it. But I've got so much data now that I'm not going to do that. And then probably it would be enough for you to just read about collecting data. And then the data that we'll be using and calculating on for the test is data that's actually been collected by students like you. All right. And then the term random variable, if you see that, well, all that just means is it works just sort of like a variable. If we have a random variable, then it's going to change every time we flip that coin. Sometimes it may be the same, but we don't know what it's going to be. That's why it's called random. Like a variable in algebra, we can, if it's X or Y and we're told that X is equal to this, well, X is going to be equal to that. But the thing about statistics and a random variable is it's going to change depending on the iteration of the experiment or the person we're interviewing and finding out their eye color. Now, we've mentioned another two key terms, which is population and a sample. Now, a population is just every member of a set under consideration. All right, kind of a universal set. And this is a good time to be taking this course because most probably you've received in the mail from the Census Bureau a list of questions they want you to ask. That is a census of the population. Okay, every person in the United States, hopefully, I don't know how they handle homeless folks that don't have a physical address, but every person that lives in the country, in theory, is being asked to answer those questions. And if you don't answer them, eventually they come by and ask you. All right, I've got so many of them before I finally had to went online and did it. But like I said, that's the population. And from a population, if we calculate and if we collect that data, we know exactly more or less what the parameters of the population are. I can't remember what some of the questions were on there, but let's just say one of the questions on that census was eye color. Well, we would know the eye color makeup of the entire population. But generally, that's something that they can only do every 10 years because it's really, really time consuming. So we can't always survey or take a census of the population. So what we do is we do a survey of a sample, which is a subset of the population. Now, it's important to make sure that that sample represents the population. And that's not an easy thing to do. So why is it hard to do? Because people tend to be biased. All right. And they're lazy. And usually what ends up happening when people take surveys is they do what's convenient. But in order to have a representative sample, it really has to be randomly taken. And what we mean by that is any element of the population has the same chance of being chosen. And the best illustration that I know of that is the lottery. When somebody plays the lottery, they're expecting that they have a chance to be chosen, that their numbers are going to be chosen. They would be, or not just they, but probably a lot of people that play the lottery would be very upset if they found out that there was cheating going on and that the lottery commission was pre-picking the winners, or those people that won were friends of the lottery commission, or if there were rich people paying off to win. Well, that's why we need to have this element of randomness. That's why when they pick those numbers out of that popcorn ball, popcorn machine is what I like to think of it as, they're chosen randomly, or as randomly as humanly possible. So that's how we need to do it. Every element has the same chance of being chosen. Now, there's several different ways you can try to go about this, and I'll just mention these because you may have a few questions in your homework about this. It's not a major issue in the course overall. Probably the most popular question I've seen on the final exam from chapter 1 is usually like distinction between sample and population. I don't know if I've ever seen anything about sampling so much, the types of sampling, but let's just mention them. Systematic sampling is very common, and it's sort of like one thing I can think about is an assembly line. It's just if in assembly line we want to test quality and we go and we get every 10th item that comes off the line and measure it. Well, that would be an example of systematic sampling. It's got weaknesses to it. So, but that's one way that people do it. Another one is stratified sampling, and cluster sampling is very similar to this. It's where you have the population divided into groups. And in stratified sampling, you're just dealing with groups that are already there. And you can kind of think of this like in New Orleans, and I guess all places are like this, but it's very common in New Orleans to talk about wards. But the city is broken up into wards. So that in by itself has already given you groups to go look at and pull your grouping, say you wanted to pull out 100 people from each one of the wards and make that part of your sample. Well, that's how stratified would work. Cluster sampling is very similar. It's just that you decide what the groups are. Maybe it's by street, or in New Orleans, it would be very hard to do it geographically because, the way the river runs, and north and south aren't really north and south, and east and west aren't really east and west. But that's just, like I said, that's why we have to have different methods in order to sample, because not everyone will work in the same way. And then convenient sampling is, like I said, usually this is one of the weakest ways to do it, because you're only picking people that kind of are near you. One of the best examples I can think of this, and I don't know if they do it anymore, but I remember back in the olden days, if you go to the mall, and I distinctly remember it, like at Oakwood, somebody would be out in front of one of the anchor stores, and as people come in, they would go up and ask me if you want to answer questions. Of course, the weakness is some people don't want to answer questions, but those people are consumers as well, so it tends to be biased. Same thing with self-sampling or voluntary sampling. I noticed that like on the WWL website, if you go on there, they always have like a question of the day, and they have at least two responses. And that's not a scientific survey. It's not a random survey. It's basically only the people that go to that website and the people that want to answer it. And it makes you wonder sometimes if people don't try to skew it by going on different computers and answering a bunch of times, if they really wanted to. So it's kind of skews thing. All right. Now this is one of the themes that you'll see throughout. Like I said, after we get into the rest, finish with chapter 1, the only thing we'll just assume that things are a random sample. All right. You won't really hear so much about sampling anymore. But these two concepts of quantitative and qualitative data are ones we'll see throughout. You notice that the first one, quantitative, as in quantity, essentially means numeric data. So continuous values can take on any number. In other words, when we say continuous, there's essentially could be, in theory, an infinite number of values. If you think about it, if you just look in between on a number line between 0 and 1, you don't think so, but there's actually an infinite number of values in there. Let's just say you take between 0 and 1 and you chop that in half, you got 1/2. Between 0 and 1/2, you chop it again, you get 1/4. You chop it again, you get 1/8, you get 1/6, 1/32. And you can keep on doing that. And you're going to have an infinite number of values just in that little section. Let alone, you could come up with a different kind of algorithm and do it at any other place. You could have done it over between 1/2 and 1. So that's why it's called continuous data, because it can take on any kind of partial values. Discrete is whole numbers only. You could say something like age at your last birthday. That's always going to be a whole number. I know that, like with kids and stuff, when they're young, they might say, well, I'm 8.5, or something like that. Generally, though, when you're talking about birthdays for normal folks, you just use what you were at your last birthday. The number of credit cards. All right, that's going to be a whole number. So quantities. Qualitative. What qualitative data is, it just means that it's not numeric. It has some kind of a descriptor about it. Descriptor. In other words, it can be broken down in two categories as well, what's called nominal and ordinal. Nominal, I think, it's kind of a Latin root word, and it simply just means name. So if you think of things like eye color, gender, hair color, what language you speak, those are all just nominal. They don't really have anything other than a descriptor, associated with them, a descriptive word. And then the other one is called ordinal. And if you look again at the first three letters on that, order, this implies that there's kind of a natural ordering to them. Okay? So drink sizes, medium, large, and jumbo. Letter grades A, B, C, D, and F. What place you finish in the marathon. And one that one of my students mentioned and they asked about yesterday, and I found a neat little picture about it. Spiciness. They mentioned I think salsa or something like that. And I tried to think about it, and I said, yeah. And I found a nice little picture. Hot, hotter, hottest. There's a natural ordering to them, and it's not numeric. Now, some data can have both. I mean, if you really want to think about this and get, very more detail than you need to, I think that there's I can't remember what it's called. There's like a number that associates with peppers. Like the hottest is 10 million. I can't remember what they call it. There's a name for it, but anyway, so it could be numeric as well. Even like letter grades, they're, like I said, they're non-numeric, but when you can calculate GPA with them because there is a numeric equivalent. All right, so there's the thing about the M&Ms. Try to remember to do that. We need to have, list 10 folks. Oh, let me make sure I got the roster here. I think for the most part I got people, and then we'll take a little break. 10 minutes. All right. So Amanda Soyas, I see. I got her. Brittany Sampson, I got. Crystal Johnson, I got. Deja Martin, I see here. Elizabeth Miller, I got. Elizabeth Thams here. Holly. How do you pronounce your last name, Holly? Is that Kalia? Kalale?
You're close, Kalila.
Kalila, okay. All right. Joel Bonnet, Mandy Zhang, Hindi. All right. So the only people I don't see. Oh, I got Jose. I see too. The only one I don't have is, let's see, Adejoke Arawaje. I might have butchered that, but I don't see it. The first one on the list. All right. So what I'm going to do is I'm going to put this on pause. Remind me to start it back up. So when you're talking about qualitative data, you've got categories that are naturally built for you. All right. So if we want to build a graphical summary for that, we've got half of the work done. What does that mean? Well, let's look. All right. The first thing we want to look at is what's called a frequency distribution. Now, a frequency distribution is a really powerful little table that allows us, instead of looking at just a bunch of raw data, to be able to see a little bit about how it's broken down. And that'll be a lot more valuable than just looking at this big block of data. So a frequency distribution, first of all, the frequency of a category is just how many of times it occurs in the data set. And a frequency distribution is a table that presents the frequency for each category. So what does that mean? Well, if you just look at this part right here, and imagine that this part is by itself for a minute. Well, we can kind of see that that's 50 elements. And they tell us up at the top because it's got 5 columns and 10 rows, so 50 of them. And what this is somebody recorded at a computer retailer the type of computer that the last 50 customers purchased. Now, in order to make that, other than this big blob of data like we see there, which is not very useful, then what we can do is go through and count it. Now, the old-fashioned kind of way to do it, it would be just to list the 4 different types in here. That's probably not too hard to do. And in reality, if you have some kind of statistical tool, and Excel works really great for this, and you had this, it would probably be all in one column, and you could sort it and easily see how many categories there were and what the categories were. But they're telling us here there's 4 categories. There's desktop, laptop, notebook, and tablet. There are no other values in here because those are the 4 categories that's broken down into, the 4 types of computers. Now, what they've done is, and like I said, this is kind of an old-fashioned way to do it. If you have a statistical tool, it's real easy to do the counts. Like I said, on Excel, you can just select everything, you know, sort them, and then select all the ones that are desktop, and you can see immediately how many there are. But back in the olden days, the way you would just kind of do with data, if you're doing it by hand, is just have these 4 things listed to the left, and then you're going to just go through, and every time you see one of these, you're going to put a downstroke, you know, a little tick mark. And I would think most people are familiar with these tally marks because what each one of these means that has a line through it, that means 5. So going through and doing this, this is what the tally marks would do for you. And if you're not using any kind of an aid to help you do it, if you got data, then tallying is a good way to do it manually. So now you can kind of see is the desktop had 5, 10, and 1, which is 11. The laptop had the most. It was 5, 10, 15, 20, 3. The notebooks, it was 5 and 4 is 9. And the tablet has 5 and 2, which is 7. Now, we don't really want to see the tally marks for the frequency distribution. So what we got is something like this. We got the type of computer. And then for the frequency, we just have the numeric value. Now, you know you've got them all because 11 and 23, what is that, 34? And 9 would be 43, plus 7 is 50. So all of the frequencies should add up to the total number of data pieces that you had, the total number of, or the total size of your data set. All right. Does that make sense? And so the frequency distribution just makes it easy to see at a glance how many you've got in each category. But there's another kind of a frequency distribution. It's called relative frequency. So instead of dealing with the count, you can essentially just deal with the decimal value or of the percent. So what does that mean? Well, this is what I'm asking you to do with your M&Ms, actually. If you've got the total number, which is kind of, you can think in this little example here, sum of all frequencies, that would be your total, the 50. And then the numerator would just be how many is in each category. So you would do this calculation 4 times. So with these numbers, you would have 11 over 50, 23 over 50, 9 over 50, 7 over 50. Whoops. And I've got that here somewhere. There it is. We didn't necessarily need to add them out because they already told us over 50, but they show you. And so that means 0.22, 0.46, 0.18, and 0.14. And you're kind of free to think of those as percents by moving the decimal over. 0.22 is 22%. 0.46 is 46%. 8.18 is 18%. And the tablet 0.14 or 14%. And if you added all those up, you're going to decimal wise get 1, and percentage wise you would get 100. Now it's important to realize that relative frequency is the same thing as proportion, because 0.22 is the proportion of desktops. 0.46 is which is just a little bit less than 50.5 is the proportion of laptops. 0.18 is the proportion of notebooks, and 0.14 is a tablet. So you're going to start seeing things where you mention that word proportion. And this is also synonymous by what we'll see in chapter 4, which is probability. Probability is the same thing as proportion and relative frequency. You can construct a bar graph . So bar graph is just a graphical representation of the frequency. And there's going to be one that's real important that we'll see towards the end. It's called a histogram. But a bar graph is just a way to graphically represent something like this. And you can use either the frequency or the relative frequency to do it. They'll both look the same. The only thing that's different is the labeling on the vertical axis. So for frequency, you're talking about the number. So there's your 11, your 23, your 9, and your 7. And then the relative frequency just does it in terms of, this is the 0.22, the 0.46, the 0.18, and the 0.14. I mean, the only thing difference between the frequency distribution and the relative frequency is just the labeling on the axis, the vertical axis. They look exactly the same otherwise. Pareto chart, it's just a fancy way of saying that you're ordering them. So we got that same thing. Notice that they order them from highest to lowest instead of the order that they were given. The laptop had the highest frequency, so it comes first, and then the desktop, and then the notebook, and the smallest one, the tablet. You can also have horizontal bars. These are not that useful, in my opinion, on statistics, but if you've got people that are trying to present information to you in an article, this could be very useful. And it's kind of useful because if you've got long categories, it's a lot easier to write out those long categories horizontally than it would be if you did it vertically, because you would have to kind of tilt your head to read them, because there's not that much room for the individual bar. You can also do things side by side, so change from year to year. Popularity of websites from 2009 to 2010. Blue is 2009, yellow is 2010. And then pie charts, although not really useful for actually calculation statistics, they can be useful for presenting the information, because people just naturally kind of understand pie charts. Because you have a pie chart, you got one whole pie. And then you can break it down into the individual proportions or relative frequencies to kind of show the proportion that each one of those has. For example, as I said, relative frequency like 0.25 can be turned into a decimal by just dropping the decimal, going over 2 spots and adding your percent sign. So here's a pie chart that represents that frequency distribution we did, the relative frequency. And you see here, they show it as relative frequency, but over here, they've got it as percent. And you can kind of see this with the laptop. Remember, 46% is just a little bit less than 50%. So it's just a shy tad of that. And there's a lot of tools to do this online. I don't know if you got any homework where they actually create a pie chart, but you can find sites that'll do them for you pretty easily if you put in the relative frequency. But you got to just remember, your relative frequencies always have to add up to 1, or your percents have to add up to 100. All right. That's why that's important, because that's the basis of what probability is. As we'll see in chapter 4, probabilities always have to add up to 1. That's the maximum the probability can ever be. All right. Now, when you're dealing with quantitative data, if the data is discrete, sometimes, and if you have relatively few outcomes, we'll see that second. But usually you have to establish some kind of classes, and they don't tell us what this is. But this is just an example one, and it's really not a good example, because generally speaking, you shouldn't have so few classes. You need at least 5, in my opinion, 5 to 7. But anyway, that's neither here nor there. But here's what we call the classes. Let's just say we've got values from 0 to 19. And when I used to have people collecting data, one of the questions was, how many keys do you have on you at the moment, And that's kind of easy to do, I could go through and count my keys, 1, 2, 3, 4, 5, 6. I got 7, like 8 keys. So you can see, if I had 8 keys, if this were keys, then I would be it would be in this little group here. So in this example, whatever this is, they don't tell us. There's 4 occurrences of values between 5 and 9, and that includes 5 and 9. For the first one, it includes 0 and it includes 4. This one includes 10 all the way up to 14, 15 all the way up to 19. And just from doing this, you would think that people probably don't carry around 19 keys, but there's a lot of people, and I think there was even some more than that. So you're kind of forced to create these classes because you really wouldn't want to have 19 generally different classes if you were to do it as discrete. But anyway, I'll show you in a minute what I'm talking about with that. But let's just use this to kind of determine a few definitions. All right. The values on the left, that whole column, are what's called the lower class limit. So anything from 0 on up to, not including 5, if there's occurrence in the data of that, then that would bump up the frequency. This one is from 5 to 9. And then on the left-hand side, that's what they call the upper class limit. That's the upper range. So notice that, let's just say that this was keys. Any value, if someone's not carrying any keys at all, 0, then they would have a tick mark in frequency. If they had 1 key, it would also go to that. 2 would also go in there. 3 go in there. 4 go in there. And notice that that's 5 values, actually. When we usually count, you don't usually count 0. But since we're not really counting so much as determining frequency, then the 0 is part of the class. All right. 5 up to 9 inclusive. 10 up to 14 inclusive. 15 to 19 inclusive. Now, as I said, there's actually 5 values in there, but the safe way to determine it is if you take any two that are right next to each other, like the 5 and the 10, and you subtract 5 from 10, you've got 5. 10 from 15 is 5. 0 from 5 is 5. Well, you can do it on the other side too. 4 from 9 is 5. 14 from 19 is 5. So that's what they call a class width of 5. When you take any 2 consecutive classes, either the lower or the upper, and subtract the smaller from the larger, that should be the class width. And generally speaking, your classes should always be the same thing. Here's kind of this basically how that works. You don't want to have any gaps. You don't want to have any overlaps, because every observation's got to fall into one category. All right. See, there's no overlap here. So 0, 1, 2, 3, and 4 would all go into the first cubby hole. 5, 6, 7, 8, and 9 would also go into the second one. And notice there's nothing in between 4 and 5. There's nothing in between 9 and 10. Nothing between 14 and 15. So there's no gaps and there's no overlap. So that way, every piece of data goes into only one and one cubby hole. So that's how these work. I don't think you ever have to really construct a frequency distribution from scratch. Usually what they do is they'll say, they'll give you the first class and they'll say, establish the rest of them. And if you got the first one, then it's easy because they already give you the class width essentially. And usually choosing the class width is the hard part because it's really arbitrary. It's really arbitrary. So that's why they choose it for you. But essentially, once you find the first class, then you can just keep, you count the number of items in there. Or if they give you the class width, you just add going down on either side. And then, of course, the lowest class has got to be small enough to include the smallest piece of data. And you got to go high enough to get the highest piece of data. If you got any pieces that you get to the end and you didn't do a class, then you got to add another class in order to put it. So let's put that into practice. Here's some actual data for 65 vehicles. And this is grams of particles per gallon of fuel. And if you go to, to get a brake tag, some places they'll measure the emissions. And this is what they essentially do. They'll run the car for a certain amount of time and then measure. And you'll just kind of notice if you look at the data, I mean, it's all spread out. And again, that's why a block of raw data is not all that useful. All right. You need to be able to order it. A frequency distribution is good for doing that. So you'll just kind of notice there's some the smallest values start with 0 point. Then you got some that's 1 point, and you got 2 points, somethings, 3 point somethings. You got some 4 point somethings. You got 5s, and I think 6s is the highest one. There's not too many of those, but they're in here. I know it. They're just not that easy to spot because there's fewer of them. Well, even if there's not, we'll see on that. But they said to construct a frequency distribution using a class of 1. Now, class width of 1. Now, like I said, I think for the most part, the homework problems will give you the first class, and because it really helps to know where to start. And why did they pick 0.0 to 0.99? Well, that's actually 1, believe it or not. And why did they do that? Well, you could start, since there were none in there that were 0.00, you could have started at 0.01 and then went up to 1.0. But here's kind of the problem, and this is why establishing classes and also just figuring class width is an art more than necessarily a science. If you have all of your classes starting with 0, first class starting with 0, that's going to make them easier to spot. So if you go through and do your tally mark, or if you organize them and sort them, you could easily go in and just find all the ones that start with a 0 and count them, and they'll tell us that there's 9 of them. See, if you went over here, we'll try it on one of them here for the first one. So there's 1, 2, 3, 4, 5, 6, 7, 8. Oops, and I skipped 1, 9. So it's really easy. That's why they made the first class all begin with 0s, and then subsequent ones starting with that whole number, because it's making them easy to count. So I said, yeah, there was a 6 in there. There was 2 of them actually. So all the frequencies here, they'll add up to 65. And then the relative frequencies are just take the 9 and divide it by 65, and the 26 by 65, and so forth. These will all add up. The frequencies will always all add up to 65. Relative frequencies will add up to 1. All right, so questions. I know I'm talking a lot, and I can just drone on because I want to, just kind of in a way want to get it over with, but we need to kind of make sure y'all are getting it, because this is usually where people kind of start getting a little bit of trouble with stuff. And usually it's not like big issues, but I just noticed that people, have questions about classes and that type of thing. So if you got a question, speak up, okay? No shame. You can also do something, click on my name and do it privately if you want to, if you ever want to not share it with everybody. All right. So now, again, we got a frequency distribution and a relative frequency distribution. All right. Now, in my opinion, the histogram is the most important tool graphically in all of statistics, because it allows us to be able to visually, and I'm really a very visual person, I could kind of see it from this frequency distribution, the way that this data is laid out. But if you look at a visual representation of this, which is called a histogram, and it plays by special rules, and the special rules are all of these classes are the same size, remember? And they're going to be touching here now because there's no gaps in between. Then this is not the one for that. I think we'll see one in a bit. But that's the way a histogram works. The little vertical distance in between those bars, notice that they're all the same size because the classes are all the same size. All right. And then the vertical represents either the frequency or the relative frequency. All right. So remember this one? That's the one we just looked at. Let's look at a histogram for it. Well, both histograms. Here's the frequency. Remember, we had 9 and we had 26, I believe it was, and 11, 13, 3, 1, and 2. Or relative frequency wise, well, that was the numbers over here. Notice that in each case, remember, since 26 was the highest value, well, they just went up to 30 just so that these things would be evenly spaced, because they're all, each one of the tick marks is 5. And likewise over here, the tallest one was 0.4, or the largest one was 0.4. So they went up to 0.5 again, just to kind of give a little bit better perspective. It's usually a good idea. Like I said, is in that way it makes all of these units 0.5. So the good thing about these histograms then is that you can, at a glance, kind of visually see how the data is spread out. In other words, starts off kind of medium high with 9, and then it goes up, and that's where you have the most right there at 26, and or between for the ones, it's got 26. The 2, anything that begins with a 2 goes up to 11. It comes back down, goes up a tad to 13 for 3, and then comes back down for 4, and then gets lower, and then comes back up a little bit. So this thing called a histogram is very useful for talking about the distribution, especially for what we call normal distribution, and then they'll initially call it approximately symmetric. Now, as I stated over here about this thing, okay, this was obviously one for that one that I said was not a good one because it only has 4 classes. Well, there's a danger in having too few classes and then also having too many. And how many is the right amount? Well, like I said, there's almost an art to it. And thankfully, you're not going to need to decide that for the most part, because usually what it is they establish that first class for you and you got the class width. So they all have already kind of done that arbitrary part for you. But just to show you why you really shouldn't have too many classes or too few. If you have too few, then you got these big chunks of things and you can't really see the detail you can in this one that's got more. You can see the detail on this, but you can't really see, well, for this long one that has 7 in it, well, what does that represent? It's somewhere around 1, a little bit more than 1. So it doesn't have the detail here. Probably a better compromise on this would be to use whole units. In other words, go from 0 to 1, 1 to 2, 2 to 3, 4 to 5, 6 to 7, and that way there would be 8 of them. All right, and then you would do the count, and then those things, it would give you a little bit more definition. Like I said, if I were going to just say a hard number, but like I said, you don't really have to worry about this. Pick no more than, no fewer than 5, and fewer than 20. Like I said, it's usually like a magic number that fits. And if you ever need to, you can get the TI-84 Plus to draw a histogram for you. You just put in the values into I think they call it an array or something. There's a name for that. You just pop them in there in a column, and then you can do the plot function, and it'll draw out for you. Last little thing about these bar charts, every once in a while you can do an open-ended class, although for the most part you want to keep all of these are the same. I think just because I'm not sure why they did this, but they left it as one open-ended class. I don't even think they even addressed that in the homework anyway. So, all right, this is the real, kind of the last little thing, and then what I mentioned. If you've got naturally established discrete data, and generally, like I said, if you don't have too many discrete values as your outcomes. And this is a good example because this was a survey of 1,000 adult women, finding out how many children they had. So everything ranges between 0 and 8. All right. There weren't any values in that. That's a good number of classes, actually. And the classes are naturally established because they're discrete, 0, 1, 2, 3, 4, 5, 6, 7, and 8. And you can look and see at a glance on that little chart how this distribution is laid out. You can see easily that over 400 women had 0 children. Almost 200 had 1. Over 200 had 2, and so forth. And that's going to be very important because a histogram can help us determine the layout of the data. And that's going to be important, especially if it's what's called symmetric. So a histogram is symmetric if its right half is a mirror image of its left. Now, in real life, there's not going to be any perfect mirror image. Like in algebra, if you had Math 130, especially, you would have certain graphs that were mirror images of one another, because algebra is kind of a perfect, dealing with perfect shapes. Whereas something like statistics, dealing with real world, we're trying to fit things close, as we'll see. There's no perfect things in reality. But it's symmetric if you've more or less got a mirror image. And this one's not perfect either, because you can kind of see, I think these two match up on either side, but these aren't quite the same height, the second ones. Neither are this one and that one. Neither are the two on the other side of the tall one. But like I said, from a histogram, you can tell the shape, and that's important. The ones that generally have this shape are going to be called approximately symmetric until we get to chapter 6, because that's going to be an important concept. It's what's called normally distributed data. And if you've got normally distributed data, things are usually a little bit easier to do. Calculations are easier. You got other kinds of data. You got skewed to the right, or right skewed, however you want to put it. And then you got left skewed, or skewed to the left. And just one thing I might mention about this, notice that it's not the side that's got most of the values. It's the side of the tail. See that? The tail determines how it's skewed. As we'll talk about things later, there's things kind of extreme values will pull and cause that tail and skewness. So I kind of like to think of it maybe like a cat. No, don't take this like I'm going grabbing my cats like this, because I don't. But you could kind of think, if you pull the tail out, their tail is getting skewed to the right, because that's the direction you're pulling it. If you pull it this direction to the left, it's skewed to the left. So again, you can also think about it as modes. The mode is just where the most of the values are laid at. So this is what on the left is what's called unimodal histogram, because there's one high bar. And there's a difference between a mode and unimodal or bimodal data, because you could still have unimodal data, a unimodal histogram, even if you had your two bars in the middle that are the same height. What makes it bimodal is it's got a hump, like a camel. Whatever those kind of camels are that have two humps. I know there's one hump camels like this, but the two humped camels, have a nice little place for you to sit in there. So if you got a nice little place to sit in the middle, it's what's called bimodal. All right, just a couple more things. We might get out a little bit early today if y'all want. Y'all can stick around and ask stuff for sure. So the last couple of little things are some other types of plots. Again, and these are kind of things you really don't do so much when you're doing statistics, but these type of things could be good for presenting information, like a time series plot or a dot plot can also be useful too for seeing the layout of data. And a stem and leaf can be, leaf can be as well. And one of the benefits of the stem and leaf is, unlike what we had over here, and I'll go back to this to show you. Not that one. See, for like this, where you got upper and lower class limits, between 0 and 4 inclusive, you know you have two values. You don't know what they are, though. Between 5 and 9 inclusive, you know you got 4. You just don't know what they are. Between 10 and 14, you got 9. You just don't know what they are, and so forth. And that may not be important for seeing the shape, but if you want to, preserve the data, then you can do something what's called a stem and leaf plot. And it'll show you the shape, but in a not so graphical way. Stem. Plots are a simple way to display small data sets. So with this, you got to have an established stem and leaf. Thankfully for this, usually they'll give you the stem and leaf because it can be different values. You can use it with all kinds of different things, like 14.8. On that, the whole number is the stem, and then the leaf is the 8. And we're going to see data that's very similar to that in a second in a real one. And you can also do it with whole numbers. You don't have to have necessarily a decimal. It just depends on the layout of the data with the stem and leaf are. So for this, the stem they're saying is 273, and we don't know what these measurements are, but that means then the leaf could have 10 different values. It could have a 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So let's look at one. So the vertical list of all the stems will be on the left. And then what you do is you can take an intermediate step and just kind of sort of like the tally thing, write the leaves down as you go across each one of the pieces of data. And then if you erase, usually they want you to arrange them and increase in order. So here's some data. As I mentioned, it's very much like that 14.8. And I bet you the 14.8 is actually in here somewhere. All right. Notice that these values, what this is the percentage of old folks over 65 in each of the states. So 50 plus District of Columbia, 51. And you'll notice this works really well because if you look at the lowest one, the land of ice and snow, where old people don't want to go up and break a hip, 8.1 is probably the lowest one in Alaska. And you can see there's other ones like Utah's 9. And then on the far end, the highest one is probably going to be Florida, since that's where all the old folks go because they can lay out by the pool and stay warm, the whole year. All right. So the values are all whole numbers, point, and then they got a tenth. So what they're going to do with this is the whole numbers is going to be the stem, and the leaf is going to be the decimal value. So how might you do it? All right, remember the lowest one was 8.1. Well, there's our 8.1. The line in this case represents the decimal. So 8.1, 9.0, that was Utah. I don't remember what these other ones were, but you got 3 of them in the tens. 10.7, 10.2, 10.5, 11.5, 11.5. So we got 2 of those. Here's where we start getting a lot of them. 12.0, 12.4, 12.7, 12.6, and blah, 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 blah. Same thing with 13. You got even more there. 14, you got a few less. Then 15, you got 116.0, and then there's Florida, 17.8. Now, notice what's good about this is that if you were to switch this like 90 degrees, in other words, put this along the bottom, lay that vertical axis down, you could kind of see that shape of how that data is laid out. So you can still see how that this is kind of approximately symmetric, and you can get all your data back if you need it, which you couldn't do with those numeric histograms that have the classes. And then this was the first step. And second step is the range them in order. They usually want you to arrange them in order, smallest to largest. Now, I'll just mention this because this is one of the things I noticed students have trouble with. They have some in there that are double ones. So this is just back-to-back stems, double ones is what I call it. And these are grades. And you got 2 sets of data. You got one for averages in an English class and one's in a history class. And the lowest seems to be 40s, and the highest, of course, is 100. So the stem is going to be the 4, the 5, the 6, 7, 8, 9, and 10. And so the English is on the right, and it's going smallest to highest as we usually read, left to right. But on the left, it's going the opposite direction. If you read it the way that we would usually read, they're going from highest to lowest. But going backwards, they're going from lowest to highest. So just watch that. That's one of the things. And if you ever have any questions, what I would suggest is, send those, like in Connect Math, there's that Ask the Instructor thing. You can send me that link. And I can kind of bring it up in class. I can also, if you just tell me what the problem is, I can look it up in mine and do it, and it'll be a similar one. And that'll give us some things to do in class. Because generally speaking, I can't spend the whole time just going over the material because the material is not really that long. So I want to use the other time to answer your questions, and that's a good way to do it. Is this the last kind? Let's see. No, there's two. There's this, and then there's those time series. All right, dot plots. They can also tell you kind of the shape and layout of the data. I mean, it's not anything really sophisticated. It's just basically a number line. So in a dot plot, basically, you're just going to put a dot for every occurrence of the piece of data. You'll have a number line going along, and then you'll just put a piece of dot. Here's some information for the number of children that each of the U.S. presidents have. I don't think it goes up to be current because if you notice some of the dates on here, they were, 10 years old. But with this, it's all discrete data. You got values from 0 to 15. So they got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So they're all equally spaced. So like I said, it's just a number line. And you can kind of see there are 6 presidents that had 0 children. As I remember, like George Washington didn't have any children of his own. I think his wife had one, but he didn't have any. I don't know of any other ones. Yeah, the guy that was single, Buchanan. But anyway, we don't need to name them. I'm just kind of giving you an idea. There's 3 that had 1 child, and then most of them had 2 children. So that's like 6, 7, 8, 9, 10. These are in order. I think they are in order now that I think about it. So that's, oh no, this might be too controversial. I think that's Thomas Jefferson if they're in order. Oh, 3rd president. Anyway. And then anyway, then for 3, there's 6 as well, and then you got 7 for 4, and so forth. So you can kind of see the shape of the data. You can kind of also see that it's more or less starts off low and gets high. It does have some kind of a symmetry to it, but these ones with 15 and 10 kind of skew it quite a bit. They pull it to that right side, the tails on the right. So this can be useful. And I think when we get to chapter 6, this is one of the methods they use to they'll give you some data in a box plot and just ask you if it's normally distributed or not. And you can tell from that. Okay, the last thing is a time series plot. This is just probably something you've seen and didn't even know what it had a name. And the reason why this can be useful is if you're taking measurements throughout a day or throughout any kind of time period, like the year or over years, a time series plot is a useful way to do it because you can kind of see progression. But what happens is the horizontal axis represents time, and the vertical axis will represent some kind of value at that time. So like, let's just say if you started at midnight and started taking the temperature every hour, you could kind of see the progression throughout the day and what happens to the temperature. It's going to probably be cool at midnight, and then it'll get cooler as it gets closer to like 5 or 6 o'clock in the morning, kind of thing. And then it'll start heating up. You get in the afternoon, especially during the summer, at 3 o'clock, 4 o'clock, that's probably the hottest part of the day, and it'll start cooling down again. So the one that we got for an example is Dow Jones Industrial Average. And so what they did here is at the end of each year from 2000 to 2009, what was the closing value? So we've got 10 values. You could kind of think of this. The year is going to be the X. It's going to be a horizontal. And the value, and notice how it jumps around, sort of like temperature or anything else. It varies. So how does that graph look? Well, like I said, is the year, the time is going to be horizontal. So they've got it spaced in equal increments of years. And then the vertical, they make it high enough to be able to accommodate the highest value, which looks to be about 13 and a half or 13 and a quarter. So they go all the way up to 14. And then what are they going to do? They're going to put a dot. So for 2000, that's the one that represents 10,786.85. 2001, 10,021.5. 2002, 8,341.63. And then it starts going back up again. This is like, right around here is the, I don't remember if it had a name. It was a recession in there. Everybody was waiting for that Y2K thing and thought it was going to happen here when we turned it, but The crash didn't happen until like a year or two later, and then it starts getting high again, and then by the end of 2007, started dropping like a rock. That's what they call the Great Recession now, the housing bubble or market crash, and it started all over. We don't have any more data on this, but it's going to start getting high again. It's actually been going up almost continually for the next eight or so years. Over the last couple 2 or 3 years, it's been more or less going up and down and not gaining anything, as far as I know. I mean, I kind of do a little bit of investing, so, but you can just see the pattern. It's not something predictable. It's just that you see what's happened. And you can, if you put in data, but you got to have 2 columns. Your your first little array would be the years, and then you got the end values. You could get it to do the graph for you if you wanted to, the calculator. All right, any questions?
For our homework, do you think it's better to print out the PowerPoints or to print out your notes?
Probably for the most part, the PowerPoints. I mean, my notes, when I have my notes, I have the things that are kind of well established and things that are kind of more universal. And like I said, as the textbook is going to key in on things, like I said, like these time series graph. I don't really have anything in the notes about that. So if you have a time series graph, it's going to be in there. Like I said, I don't think it's that important in the great scope of things. Like I said, I think that for the most part, the histogram is the most important thing. But for the homework, you're going into, and usually like the little quizzes, you'll see things that deal with these little intricacies that are in the PowerPoints. Yes.
Okay. Thank you.
All right, I'm going to pause this so it doesn't take it too long.